Alright, so in this video we'll talk about the poles and zeros of h of z, or the transfer function or system function, the different names it is known as. So basically, before we jump into calculation and how it is calculated, I'll just go over what it really means to have the poles and zeros. So a zero is when the h of z is equal to 0. That's basically called a zero. So when this function evaluates to 0 for those z's, those are basically called the zeros of h of z. And when h of z evaluates to infinity or undefined, those are known as the poles. For those points of z, those are known as the poles of the graph. So in this graph, this is called a pole zero plot. So over here in this plot, the x mark represents the poles and the circles represent the zeros. So, and this 3 number means that there are 3 poles and they're all at this place. So in this graph, basically what it means is that for these frequencies or at these places, the frequency response, these are the zeros. So at these places, if you are sending in an input signal, this basically makes filters out these particular frequencies out, and the poles basically means that will let these frequencies go through. So basically why you need a poles and zeros is because it's a very good representation of filters of how it works. So if it lets certain frequencies go, you can easily represent it in this format. And even when you have to make your own filters, say you have a signal and you have an interference at a particular frequency, so you're trying to get rid of that noise or that interference. So in that case, you need to make your own custom filter. So how you could do that is by placing zeros at the frequencies you want to null out, and that's how you can derive a function of the filter. And this is basically how poles and zeros relate to the frequency response. And in the next video, I will do some examples of how we can calculate when h of z is equal to 0, and how we can determine h of z, where are the poles of the function.